Now here we will be discussing about exponential and logarithmic functions. Let's first discuss about exponential functions. Now y, which is equal to a function of x, is equal to b power x, where b is positive and b is greater than 1, is called an exponential function. Now if b is equal to 10, we will have a graph like this for f of x. So this is the graph of the function f of x is equal to b power x. You can observe that the graph cuts the y-axis at the point 0, 1. Now we have a few characteristics of the exponential function or few properties of the exponential function, which is the domain of f of x is the set of all real numbers R. Now what about the range of f of x? So whatever be the value of x, we will have b power x to be always positive. Therefore, the range of f of x is all positive real numbers. As seen from the graph, it always intersects the y-axis at 0, 1. So this is y is equal to b power x. So graph cuts y-axis at 0, 1, and we can see that the function is ever increasing, an increasing function. So the exponential function is always an increasing function. Then now for really high negative values of x, we can see that the graph will slowly approach to touch the x-axis, but it is never going to touch that. So for large negative values of x, the graph almost touches x-axis. Now if f of x is equal to 10 power x, then we call such a function as common exponential function. And if f of x is equal to e power x, we say this as natural exponential function. Now let us discuss about logarithmic function. If b is greater than 1 and it is a real number, then logarithm of a to the base b is x if b power x is equal to a. That is, we have log a to the base b is equal to x. Now if the base b is equal to 10, we call such logarithms as common logarithms, and if the base b is equal to e, then we call such logarithms as natural logarithms. So natural logarithms are also often referred to as ln or ln, but if the base is not specified, we will take such logarithms to be natural logarithms. Now let us see how the graph of the logarithmic function is going to be. It is going to be like this. So this is y is equal to log x to the base e. And just as how we saw for exponential functions. Let's see the domain, range, etc. for this function. So the domain of f of x is set of all positive real numbers. The range, whereas, is set of all real numbers. So this point, which is the point of intersection of the graph with the x-axis, is 1, 0. So 1, 0 always lies on the graph. And we can also see that the function is an ever increasing function. And when x is going to approach 0, we can see that the graph will slowly try to touch the y-axis, but it will never do so. So if x is very close to 0, the graph tends to touch the y-axis. So if y is equal to logarithm of x to the base e, then the derivative of y with respect to x is given by 1 by x. And if y is equal to the exponential function e power x, then the derivative of e power x is e power x itself. Now we have been given a function y equal to log of sine of e power x. We have to find dy by dx. Now differentiate both sides with respect to x. We get dy by dx is equal to d by dx of log sine of e power x. Now what is the derivative of log function? It is nothing but 1 by x. So here in place of x we have sine of e power x. So it is 1 by sine of e power x into d by dx of sine of e power x. So this is 1 by sine of e power x into the derivative of sine function is cos function. So it is cos of e power x into the derivative of e power x. So this is nothing but cos of e power x divided by sine of e power x into e power x, because the derivative of the exponential function is the exponential function itself. So this is equal to cot of e power x into e power x, or dy by dx is e power x cot of e power x.